Good morning, everybody. This is a live severe weather briefing as I still anticipate a tornado outbreak beginning tonight, actually, and continuing through tomorrow into the overnight hours tomorrow night. There are still some weaknesses with the setup, but that does not mean that it's not going to be a large-scale tornado outbreak. Some of those weaknesses include an abundance of precipitation developing overnight tonight, maybe limiting the northward advancement of that warm front. Another negative that I do see with this forecast is the westward extension of that subtropical ridge across the Gulf of Mexico, leading to a more quickly sheared out upper level storm system. But it is that tandem trough ejection. Look at that close low off of Baja, diving out in front of the parent system that's diving southward through the Pacific Northwest. A very similar trough ejection to December 10 and 11, but that does not mean that exactly the same thing is going to happen. That's definitely not the case. And as is the case with even the most prolific tornado outbreaks, a majority of the locations within the risk area are not impacted by that tornado, and tornadoes are relatively small swaths. So no reason to panic. Even if you do nothing and just sit there and don't even stay tuned to the warnings, chances are you're probably not going to be hit by the tornado. But it's very important to stay tuned to those warnings, have a severe weather safety plan in place, and if a tornado does strike, if you do find yourself in the path of a tornado, then you'll know exactly what to do. But definitely an enhanced risk has been issued. That is from northeastern Louisiana, across eastern Arkansas as well, all the way up to southern Indiana. But the northward progression of that warm front is definitely in question. The NAM model is a lot more aggressive, lifting that warm front all the way up past the Ohio River Valley. The HRRR model is less aggressive with the abundance of precipitation, maybe limiting the rapid northward progression of that warm front. But with a 70-knot southwesterly low-level jet, that warm front still goes all the way up northward to the Ohio River Valley. And here is that Cape loop, and it shows you that the Cape definitely evolves today as well. And so definitely do not sleep on the tornado threat tonight, even though it is preceding the main outbreak that is going to be coming in on January 1st. I do expect warm advection supercells to develop, possibly northeastern Texas through central Arkansas, all the way up into western Tennessee tonight. There you can see that instability lifting up northward overnight tonight. And any storms that are able to develop along that warm frontal zone that's going to be lifting up through central Arkansas and through western Tennessee, even northern Mississippi this evening, will have some tornado potential as well with that rapid warm advection. And if there is an abundance of precipitation tonight, that is a bit of a failure scenario as well for this tornado potential. There you can see the loop of the 0 to 1 kilometer EHI, the Energy Helicity Index, that basically shows you the co-location of that surface-based instability with 0 to 1 kilometer shear. And so in terms of a target area for storm chasing, I am trying to determine whether to target that northern mode across western into central Kentucky, maybe even into southern Indiana area, a little bit of a northern mode up there. It is possible it could have a bit less instability. There also is a southern mode that evolves down across central Mississippi into central and northern Alabama. That one develops a little bit later, about 5 or 6 p.m. But this is the tandem trough ejection that I've been talking about for days. This is also the tandem trough ejection that we identified before the December 10 and 11 event. And you can see this parent trough diving southward through the Pacific Northwest. You can also see this closed upper low, basically in a slingshot mechanism, getting picked up off of Southern California and Baja, lifting off to the northeast as this parent trough dives off to the south, and as this lifts off to the northwest. See how this subtropical anticyclone extends into the Gulf of Mexico here. It extends a little bit further west than it did on December 10 and 11. And it's possible that could cause the system to shear out a little bit earlier and would lead to, in general, a more southwest and northeast orientation of those convective lines and the wind shear parallel to that. That would be a best case scenario, but I still think a tornado outbreak would still be possible with that scenario. And remember that the meteorological definition of a tornado outbreak is greater than 6 tornadoes over a given region during a 12 to 24-hour period. And it's a scientific definition. It's not an emotional one. And so when I use the word tornado outbreak, I mean that there's a potential of a tornado outbreak, or at least 6 tornadoes over a given region. With this type of a setup, You could even see dozens of tornadoes because the warm sector is so large over a multiple state area, but still those individual tornado tracks are discrete tracks of damage. And even during a tornado outbreak, a majority of that terrain in the warm sector is not actually impacted by a tornado. But the key is to anticipate some of these worst case scenarios, have a safety plan in place, no need to panic. I'm definitely not very good at dealing with human emotion. I am good at dealing with the forecast models, storm chasing, forecasting as well. So really all I can do is communicate to you my meteorological thoughts on these setups. Definitely not a communications major at all. I'm just a pure raw storm chaser meteorologist trying to communicate to you my thoughts on this forecast based on analyzing these events for the last 25 years, looking at the models with obsession, with intense passion, and also storm chasing these nonstop as well. But here you can see this slightly negatively tilted embedded trough out ahead of this parent trough diving south through the Pacific Northwest. This tandem trough ejection is definitely a sign, usually of pretty widespread severe weather events, and that's because it moves over the Mexican plateau like this, picks up that dry air in the mid-levels of the atmosphere. You already have a lot of moisture in place over the Gulf of Mexico, largely because of this strong subtropical ridge that's in place and because the sea surface temperatures are simply so warm down there in the Gulf of Mexico. So you basically have this reservoir of big-time moisture sitting here over the Mid-South and the Gulf of Mexico. You have this embedded trough here with the parent trough with a slight positive tilt diving south through the western U.S., and this thing is just going to eject over that warm sector. And during the night tonight, you could see this belt of warm advection showers here. Even though you have this anticyclonic curvature aloft, you get a lot of warm advection up there. Look at that southwesterly low-level jet. This is late night tonight into the early morning hours. And right on the nose of that strong 50-knot low-level jet, you get the development of this arc of convection right along that warm front. And any of these storms, if you get discrete supercells that are embedded within that environment and a little bit off to the south of it, you can certainly get tornado potential. Many of the convective allowing models are showing a nocturnal event developing along that arc there, northeastern Texas, all the way up across the Ozark Mountain region. And this storm, if it lights up overnight tonight, then at least it should slow the rapid northward progression of that warm front. Hopefully it doesn't lift all the way up to Indianapolis or southwestern Ohio, and there is an abundance of precipitation. But even if it stalls out at the Ohio River Valley, to the south of it, you're going to have an unstable and strongly sheared warm sector with that low-level jet there. And that enhanced low-level jet is in front of this embedded trough here, a negatively tilted trough just ripping around the east side of that trough axis. So the severity really of this outbreak depends on how well will this embedded trough axis here be able to maintain its identity and its spin as opposed to shearing out as more of a jet streak, which still would cause problems there. It would still create lift, more wind shear as well. I think usually these closed upper lows that come in off the Baja are able to maintain their spin or maintain their identity a little bit longer than the forecast models will show. That's what happened during the December 10 and 11 event. You could see it on radar just pumping into the Arklatex right into those developing storms near central Arkansas, and that led to a very long track supercell, that quad state supercell. You also had tornadoes further north across central and southern Illinois in fact, some strong to violent tornadoes up there as well, that one that hit the Amazon plant. But this is the forecast for tomorrow morning. You could see this trough ejecting through the southeastern plains, your parent trough still back behind it. Overall, this tandem trough ejection, though, dominates the western U.S. Trough, ridge pattern, generally favorable for big-time severe weather. The squeeze play in between this anticyclone over the Gulf of Mexico and the southeastern U.S. and this trough is what creates that strong low-level jet. And with this system ejecting out in front of it, it helps to also expand that low-level jet over a multiple state area. And in fact, once again, this monster low-level jet covers multiple states. And I use that term just to describe an extra large low-level jet that's covering multiple states ahead of a megatrough like this. It's simply a massive low-level jet just slamming up against that warm front. It is a little bit veered, and with that precipitation off to the north, that could limit that warm front's advance probably will reach the Ohio River Valley. So it does look like Kentucky is going to be well inside of that low-level jet. And it ramps up during the day, January 1st. I mean, that's a 70-plus knot low-level jet. Western Tennessee, nosing up into central Kentucky there, eventually becoming more parallel to that warm front as it noses all the way up to that Illinois, Indiana, Kentucky intersection there. And that low-level jet extends all the way to the south. So as is often the case with these big outbreaks like this, you're likely going to have a cluster of tornadoes off to the north and a cluster of tornadoes off to the south. We call that a bimodal type of an outbreak. You generally have stronger wind shear off to the north, stronger instability off to the south, but still sufficient wind shear for that tornado threat. In this case, you got a 60-knot low-level jet from basically the Louisiana-Mississippi border all the way up through the state, this entire state of Mississippi, almost the entire state of Tennessee and Kentucky, even to the east side of the Appalachians. That low-level jet takes off. And these are the 12Z models here. That's at 20Z, 22Z, and that convective line starting to progress eastern Arkansas all the way up. And then you're going to get that mode of renegades that develop down here, eastern Louisiana through central Mississippi, central northern Alabama as well. Let's zoom in a little bit closer after this. First of all, see how the low-level jet progresses. This is 2Z, still a very strong low-level jet. Middle Tennessee into south central Kentucky, and now encompassing the entire state of Alabama by 2Z. That's where I'm located right now. Very favorable photographs throughout the warm sector. And that's why I threw out the word tornado outbreak, because conditions are favorable for tornadoes over a large area. You're expecting a large number of storms. It's just the nature of things here in the Mid-South. You have a large area of uncapped warm sector. You get prefrontal confluence lines that develop supercell storms. And even though the storm motions are a lot faster and it's difficult to keep up with those tornadoes as a storm chaser, these moving at 60, 70 miles an hour, there's a greater number of storms. So you just hop down the line and intercept wave after wave of these storms. And look at that directional shear as well, even in the overnight. Despite that southwesterly low-level jet, southerly surface winds relatively weak. Your elevated mixed layer right here, dry pocket of air coming in the mid-levels of the atmosphere. It picks that up over the Mexican plateau, over northern Mexico. That's where you get that dry pocket of air aloft, and that's what creates that instability. And it's possible there could be a severe weather threat the next day on the 2nd, but most of the models are pinching off that instability off over the southeast, and so the kinematics get a little bit detached from the more favorable instability. So let's zoom in a little bit closer. And let's look at some of the convective allowing models in the evolution. You never want to get too focused on the convective allowing models. Some of these suits will just look at outdated convective outlooks, post them to make a weird point on the human psychology. Sometimes people will just look at these composite reflectivity forecasts of the models and make comments on storm mode or the expected evolution. But a lot of people are doing good work out here. So here is the HRRR at 20Z, showing you that max in the low-level jet. And I want you to focus on the shape of this boundary. Notice how it's more southwest to northeast off to the south, and then it shoots due north here across western Tennessee. Those storms are going to have a greater likelihood of being able to move off of that boundary as well and possibly become discrete across this area, western Tennessee into south central Kentucky. But you also have these prefrontal confluence lines, that one that often sets up from central Mississippi into central Alabama, and that's also going to be a corridor for those renegade supercells that likely will develop a little bit later, a little bit closer to that Cape blob down there as well. And the models are definitely showing a squall line that is going to be in place, and it's a little bit different. There are definitely differences on the mesoscale and smaller scale based on the shape of that subtropical ridge that's extending west through the Gulf of Mexico. Basically, you get this broken line of storms that extends all the way from East Texas through southeastern Arkansas. This is pushing into the middle part of the afternoon tomorrow, and going all the way up to the Ohio River. A lot of rain up here, though, to the north of the Ohio River. Should slow the northward progression of that warm front and a relatively veered low-level jet there, even though it is going to be slamming into that warm front. Probably will advance into southern Ohio, southwestern Ohio. The HRRR is indicating the threat of these renegades as well, just ahead of the line, and also is suggesting the development of these renegades further to the southwest across central and northern Mississippi. But notice how the models don't really show those discrete storms that are moving off that boundary where it is more of a north-south direction. I still think that they're going to be able to move off of that very easily, and you're likely going to get this corridor of renegades forming from northeastern Louisiana across central northern Alabama, eventually pushing east. And this squall line, even if it does look more linear like this, when it's moving into a 70-knot southwesterly low-level jet, it is just simply going to have a greater potential of having tornadoes embedded within it. And it does look like the HRRR is underdoing these dew points a bit down in that warm sector, even showing a little bit of some dry pockets there. Interestingly showing those dry pockets. You look at the 3-kilometer NAM. I wonder if it is even underdoing the coverage of those storms. The 3-kilometer NAM certainly has a better handle on these greater dew points, upper 60s dew points, near 70 dew points streaming up north. They're already in place here in the Mid-South. So I do believe that the instability as depicted by the 3-kilometer NAM is a bit more accurate. And it does have this kink within the line a bit further east than the HRRR is showing. So would you want to play that kink or this kink further south, central Arkansas into eastern Arkansas? That also could as well be a play. Maybe this moisture nose into northern Mississippi. That's the difficult part of targeting these outbreaks, is there are so many facets of tornado potential across such a large area that as a storm chaser, it is difficult to chase these setups. That's why it's very easy just to sit down and analyze the models and the radar, from a comfort of your own home or studio and break these down. But when you're driving around nonstop, it can be difficult as well to figure out and keep track of all these different modes of this outbreak. But all I can do is sling these weather briefings and tell you what I think. And looks like the good news is at least the 3-kilometer NAM, this new 3-kilometer NAM, doesn't rocket that warm front all the way to Indianapolis. All the precipitation there should help. And it also, look at the 3-kilometer NAM, keeps that instability to the south of Kentucky. You do get that round with that lead wave a little bit earlier in the afternoon that progresses across south central Kentucky, and then you get the building up of this next round coming in into western Tennessee, northern Mississippi there. That's all Cape. You can look at the 0 to 1 kilometer EHI to show you that best co-location of that instability. So this is some good news that's coming in, is that abundance of precipitation will probably keep that warm front from advancing too far north or maybe even approaching the Ohio River Valley. Should have a corridor of some renegades here as well, central Mississippi and northwestern Alabama. But this should be that main event then, lifting through central western Tennessee. Good news is that with this new model guidance is it does have an abundance of precipitation north of the warm front. Bad news is, though, is that the 3-kilometer NAM is showing an outbreak here. Renegades developing back into central Mississippi, spreading eventually into northwestern Alabama. Renegades here, western Tennessee as well, into central Tennessee. And it's just a question as to how far north does that instability axis move. That's at 2Z, so that's about 8 p.m. Those nocturnal storms are going to be evolving. This is at 22Z. Might even end up being in a northeastern Arkansas, western Tennessee type of a location. 20Z. So it does appear to be slowing down just a bit. A lot of model discrepancy still with these tandem trough ejections. But the new model guidance just suggests maybe a further west location would be ideal for this. Storms initiating early to middle afternoon across central Arkansas, lifting off to the northeast, eventually arriving there into western Tennessee. I would say Memphis, Need to keep an eye on this. And look at this streak here, this intense low-level jet that's right in that corridor of where those supercells are going to evolve, that prefrontal confluence line, central northern Mississippi. And you can certainly see that strong wind shear in place. Big low-level jet as that convective line is pushing off to the east. And then you have that convective line approaching the Memphis area. A couple of renegades there in the northwestern portion of the state. This is at 23Z now, 5 or 6 p.m. Those renegades develop over western Tennessee at about 4 p.m. and then move back into far southern Kentucky before lifting north of that warm front. So it does have the warm front a lot further south. This location across western Tennessee looks to be the strongest wind shear relative to this setup, but you do have this threat of those renegades developing a bit later, after dark as well. These are those renegades pushing in central northern Mississippi, and the models lift those up through northwestern Alabama into south central Mississippi. Keep an eye on those as well. So I do think that this is going to be a pretty widespread tornado outbreak. The latest models, though, at least are showing that warm front a bit further south, not advancing all the way northward past the Ohio River Valley. Hopefully, there's an abundance of precipitation tonight, and that'll keep the warm front even further south of those areas that were ravaged by the December 10 and 11 tornado outbreak. But we're just going to have to keep analyzing these models during the day today, through tonight, through tomorrow morning. I'll continue to do these live weather briefings for you. So thank you, everybody, for tuning in to this weather report. We do have that enhanced risk as issued by the Storm Prediction Center. I do think that there is a pretty substantial chance of this getting upgraded to a moderate risk as well. That might be by tomorrow morning. Might be during the day tomorrow once that the model discrepancies start to iron themselves out just a little bit. But I definitely agree with that outlook. Definitely the models at least are coming into agreement with this enhanced risk. And I do think that there is going to be an upgrade. We do have that 10% hatch area across the enhanced risk. So definitely dial in those severe weather safety plans. Of course, no need to panic this far in advance of the severe weather. Just be prepared and get those severe weather safety plans dialed in. And I'll be doing these live weather briefings leading up. And of course, I'll be out there storm chasing down these very fast storm motions at about 60 to 70 knots. So thank you, everybody, for tuning into this weather report. Never stop chasing.